All right, precalculus, last portion of 4.1. Sorry to drag this section out, but this does come back quite a bit with coterminal angles. So as we've seen, we've dealt with angles that are a bit much. In the previous example, we saw this 690 that we had to map out, and that was a lot of rotation. That was a bit too much. In reality, the coterminal angle helps us get to that same position, but without as many circles that we have to run through. So this says that by increasing or decreasing the degree measure of an angle in standard position with multiples of 360 degrees, we get our coterminal angle, where if we took the angle and we added or subtracted intervals of 360 degrees, we end up with the angle that makes the most sense, where we could have just cut right to the chase and said, oh, that's where it is. Duh. We didn't have to go in circles finding it. So with this example, 420 degrees, we know that that would circle around the circle definitely one time because it's more than 360 degrees. So in that case, we would subtract 360 from 420, and we see that 60 degrees ends up in that same spot. If you're not convinced, you can try this one out. So with this one, we're going to measure 420 degrees. Again, we always start towards the right and we go counterclockwise. So that's 90, 80, 270, 360, and then if we're going for that 60 degree portion that we still need for the 420, it gets us to here. So we could say that this is where the measurement is after 420 degrees, or we could just lump up to 60 degrees and say, oh, that's where it is. Easy. Easy enough, at least. We'll try this out with 870. Well, I know that this is going around quite a bit, so recall that we're trying to get our answer less than 360, or if we're dealing with radians, less than 2 pi. So with 870 degrees, let's just try it out. Let's deduct 360. That would get us 510, which is a bit too much, so let's keep going. So let's deduct 360 degrees again. That should get us 150 degrees, which satisfies our condition where we want this angle to be less than 360 degrees. So if we were going to graph this out on a unit circle, we would be taking a full 360, a second interval of 360 degrees, and then we just go to 150 degrees, which is probably right here, which, if you think about that, makes sense that it would be about 150 degrees for our coterminal angle. Simple enough. We now see a negative number in degrees, so let's just keep on adding 360 and see where that goes. So that should get us to, let's see, 155, and it's negative. So we still got more to do, so let's add on 360 again. If we do that, let's see, well, sometimes you get stuck on these and you might need a calculator, so feel free to use it. So we have 360, and we're deducting 155, 205 degrees. And again, this satisfies the condition because it's less than 360. So, all right, sounds like we're okay. With radians, this can be a bit tricky. So I, in this case, would look at the denominator of 7, and I would think out, I know that I want to deduct, 360 or 2 pi in this case because we're in radians, so you're going to have to find a way to deduct 2 pi, but with the fraction. So how this works for me, I take the denominator, which is still 7. Nothing's going to change there. And then I also throw in the terms of pi, because we need that. And I just think of the denominator, multiply it by 2, and that would be 14. So there we go. Boom. All right, well, easy enough. We have this set up here where we're going to be deducting 2 pi. So let's take this to the fraction itself. So we have 38 pi over 7, and we're deducting 14 pi over 7. Our denominators are the same, so we just keep deducting from the top. So this is going to be equal to 48 minus 14. That's going to be 28 pi over 7. Well, we're not quite in that range of less than 14, so let's do it one more time. Let's subtract 14 pi over 7 one more time. This is equal to 14 pi over 7. Oh, sorry, I forgot to get rid of it. All right, so 24 pi minus 14 pi gets us 10 pi over 7. That's less than the 14, so 10 pi over 7 works for us. I'll give you a moment, try the next one out. So remember that we want to reuse the denominator, in this case 9. If we multiply that by 2, 18 pi over 9 is what we're going to have to keep adding to this setup here. So let's take negative 10 pi over 9. Let's add on 18 pi over 9. Again, the reason we do this is because we want to keep adding 360 degrees, similar to what we did here, or subtracting 360 degrees. Since it's negative, we're going to be adding. So if we do this, this is going to get us to positive 8 pi over 9, which is less than 2 pi over. So that's a good thing. Hope this was helpful. This section, again, is tough, but take your time, ask questions if you're stuck. Thanks for watching.